Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0615, indicates a malfunction in the starter cut relay diagnosis circuit. In Honda vehicles, particularly the Civic model from 2016 to 2021, this error code signals that there is an issue with the relay circuit responsible for ensuring the starter can operate effectively. The starter cut relay plays a crucial role in preventing the engine from inadvertently starting, which can occur due to various electrical faults. This relay is typically located within the under-dash fuse relay box. When malfunctioning, the circuit may not send the appropriate signal to the powertrain control module, PCM, leading to difficulties in starting the vehicle. In this troubleshooting guide, we will explore the steps necessary to identify and rectify the causes of DTC P0615. DTC P0615 pertains to a malfunction detected within the starter cut relay diagnosis circuit, specifically highlighting a communication issue between the relay and the powertrain control module, PCM. The starter cut relay is integral to safely starting the engine by preventing unintended starts under certain conditions. It ensures that only when everything is confirmed as operational can the engine turn over. This relay is generally situated inside the under-dash fuse relay box, which is commonly found beneath the dashboard on the driver's side. Given this location, the relay is easily accessible for inspection and testing. Problems in this circuit can lead to symptoms such as failure to start or intermittent starting issues, which can frustrate users and lead to concerns about vehicle reliability. There are several potential causes for DTC P0615 that warrant consideration during the diagnostic process. One of the primary culprits can be poor connections or loose terminals at the relay circuit board or the PCM. Such issues can lead to intermittent failures where the system operates sporadically, making it seem as though the vehicle's electrical system is functioning as expected. In addition, a malfunctioning PCM may fail to send or receive the necessary signals, leading to a disconnect in proper relay function. Another possible cause is an open wire in the starter relay 1 to 2 line, which can disrupt communication. Identifying these conditions early on can save time and improve the accuracy of the diagnostic process. The manifestations of DTC P0615 can significantly impact vehicle operation. A primary symptom is the engine's failure to start, which can leave drivers stranded. Additionally, drivers may experience intermittent starting issues, where the car may start successfully at times, but not at others, adding to the frustration. These unpredictable behaviors can often be traced directly back to problems in the starter cut relay circuit or associated wiring. Drivers may also notice that the DTC indicator light illuminates on the dashboard, alerting them to the malfunction within the starting system. Recognizing these symptoms early is vital for effective troubleshooting and timely repairs, thus maintaining vehicle reliability and performance. The first step in troubleshooting DTC P0615 begins with turning the vehicle ignition to the on position. This mode allows the onboard systems to initialize. Next, using the Honda Diagnostic System HDS, clear any existing diagnostic trouble codes. This action resets the system and allows for a fresh assessment of the vehicle's performance. After clearing the DTC, attempt to start the engine. Observing the response of the engine in this stage is crucial. Monitoring for any new pending or confirmed DTCs using the HDS will provide essential data on whether the system is functioning correctly or if the DTC P0615 reappears. If the code is indicated again, it confirms the failure exists. If not, it may suggest an intermittent issue needing further investigation. The second troubleshooting step involves checking for any pending or confirmed DTCs once again using HDS. This check is critical as it helps determine if related issues are present. Specifically, look for additional codes, namely P16F3 and P16F4, which indicate low voltage on the starter cut relay, 1 and 2 control circuits, respectively. If these are present, it suggests that there may be multiple faults needing attention, and you should follow the specific troubleshooting procedures for those codes. Conversely, if neither P16F3 nor P16F4 is indicated, you can proceed to further steps in troubleshooting the original DTC P0615. Understanding the relationships between these codes can greatly enhance the effectiveness of the diagnostic process. In Step 3, the focus shifts to identifying the possible failure area related to DTC P0615. First, turn the vehicle ignition to the on mode, as this engages the necessary electrical systems without starting the engine. The next action involves an important test, attempting to start the engine. If it successfully starts, it may suggest the issue lies within the relay circuit wiring rather than the starter itself. However, if the engine does not start, it indicates a more serious underlying problem requiring further investigation. Understanding whether the engine starts under these conditions not only aids in pinpointing the issue, but also informs the next steps for troubleshooting the circuit effectively. Step 4 involves conducting an open wire check, specifically for the STRLY 1-2 line, which is essential for confirming the integrity of the relay circuit. Start by turning the vehicle to the off-lock mode, ensuring all systems are deactivated. Afterward, use the HDS to jump the SCS line, allowing for comprehensive diagnostics of the circuit. Disconnect the relevant connectors, including the PCM connector A50P and the relay circuit board connector A8P. With these connectors detached, check for continuity between the designated test points in the circuit. This check is crucial. If continuity exists, it indicates the wire is functional, implying the issue could lie in other connected components, such as the PCM. If continuity is absent, this leads to a diagnosis of an open circuit that must be repaired. The fifth troubleshooting step requires the inspection of fuse number B21, as it is pertinent to the relay circuit's function. Begin this step by turning the vehicle to the off-lock mode, which allows for safe handling of electrical components. Locate fuse number B21, rated at 10 AA, which is situated in the under-dash fuse/relay box. Inspecting this fuse is critical, as a blown fuse can interrupt the electrical flow necessary for the starter relay to function. If the fuse is found to be defective, it may also signal a short circuit existing in the IG1 ACG wire, which needs further investigation. Should the fuse be intact, proceed with additional testing to resolve any underlying issues affecting the starter cut relay circuit. In this step of the troubleshooting procedure, the focus narrows to the IG1 ACG line. Disconnect the necessary connectors, including the under-dash fuse relay box connector C and relay circuit board connector B. This disconnection allows you to safely check for continuity within the circuit without cross-interferences. Next, to verify functionality, connect terminals A and B with a jumper wire, linking terminal A from connector C to the body ground. This action sets up the parameters for a continuity test. Ensure the vehicle remains in the off-lock mode while verifying continuity between the specified test points. A positive continuity result indicates the integrity of the circuit, while a lack of continuity requires further inspection and repair of the IG1 ACG wire leading to the relay circuit board. The final troubleshooting step involves inspecting the relay circuit board directly. Start by removing the relay circuit board for examination and functionality testing. The integrity of this component is vital to the proper operation of the starter cut relay. If testing reveals that the relay circuit board is functional, then the next action would be to replace the entire under-dash fuse relay box to ensure that all components are operational and to eliminate potential issues. Conversely, if testing indicates that the relay circuit board is faulty, replacement of just this component is sufficient. This step underscores the importance of component testing in diagnosing electrical issues, ensuring that repairs are both effective and efficient. After completing all necessary repairs related to DTC P0615, it is essential to conduct a final verification to ensure that the vehicle is operating as intended. Start by retesting for any diagnostic trouble codes using the HDS to confirm that DTC P0615 and any other related codes have been cleared from the system. Next, evaluate the engine performance to ensure that it starts without issues and operates smoothly. Keeping a record of these checks is vital, as it confirms that all repairs have been successful. If no further DTCs reappear and the vehicle runs reliably, it indicates that the issues have been effectively resolved. This verification step is crucial for maintaining standards of quality and safety in automotive repair processes. Preventive maintenance plays a critical role in mitigating future DTC occurrences, including DTC P0615. A proactive approach includes regular inspection of all electrical connectors related to the starter cut relay system. Look for signs of corrosion or looseness, as these can lead to poor connectivity and intermittent issues. Routine checks of the fuse, specifically fuse number B21, should also be a key part of the maintenance schedule. Monitoring the overall health of the electrical system helps detect early warning signs of potential issues, allowing for timely interventions before they escalate into significant problems. Establishing these preventive measures will enhance the reliability of the vehicle's starting system and prolong its operational lifespan. In conclusion, diagnosing DTC P0615 involves understanding the starter cut relay diagnosis circuit's intricacies within Honda Civics from 2016 to 2021. This particular DTC highlights the importance of a comprehensive approach to troubleshooting, considering potential causes like poor connections, malfunctioning components, and wire integrity. Recognizing symptoms early can expedite repairs and enhance overall vehicle reliability. Emphasizing regular preventive maintenance, such as inspecting connectors and fuses, ensures that possible faults are identified before they lead to critical failures. The steps we've discussed illustrate the significance of methodical diagnostics and diligent upkeep, ensuring your Honda Civic remains in optimal working condition. Please like and subscribe to the channel. See you next time!